Here we start with Chapter 2 now. You can see that there are 6 sections in Chapter 2, and what we're going to be dealing with mostly is linear equations of the form y equals mx plus b. We're going to be doing later on dealing with some graphing some inequalities and learning how to shade them, and then intersections and where they take place, and the nonlinear graphs and inequalities. So some fun stuff. It ought to be a review for us. So I don't think that we're going to spend a lot of time necessarily here. I believe we can just move through. As I've studied this chapter, it looks like there's not a lot for me to really say too much. Just point out a few things for you and let you work them together. You've already had this, had it last year, and so it'll be a bit of a review. So here we are taking a look at the learning goals. We're going to be able to complete tables and graphs and write equations to match. Obviously analyze multiple representations of linear relationships. Identify some units of measure associated with linear relationships. Determine solutions both graphically and algebraically. And determine solutions to linear functions using intersection points. Our key terms, we're going to talk about first differences, solution, and intersection point. The whole premise of this particular section is built around the fact of an airplane taking off. I'm sure that many of you have flown in an airplane before, and you know that you get in the airplane and fasten your seatbelt. The flight attendants come in and tell you to turn off all your electronic devices. They don't want any interference with ground control in the airplane while it is ascending. Then you taxi out, stop at the end of the runway. The pilot will then sometimes rev up the engine and let go. Sometimes they just turn the corner and go. And then you leave the ground and you start to ascend. And the ascent is what we would refer to as linear. You continue to just climb at the same rate until you reach your cruising altitude of 30,000 or 28,000 or whatever it is that the flight plan has in store. But it's a steady climb. It never changes. It never goes faster. It never goes slower. It just accelerates at the same rate. And then when you pass through 10,000 feet, the pilot will come back on, or maybe one of the flight attendants, and tell you that you can now turn on your laptops and your electronic devices. Can't use your cell phones. Most of the cell phones today have what is known as airplane mode, so that you can turn your cell phone on and turn it to airplane mode, and then you can use your phone for things other than calling. And so this whole thing is going to be talked about, or this whole section is talking about that airplane and its acceleration, what happens when it gets to cruising altitude, what's the graph going to look like, what's the equation, what's the rate, all of that is going to be a part of this section. Okay, we're going to ask you to read this little problem, a 747, initial climb rate of 1,800 feet per minute till it reaches the height of 10,000 feet. We are only looking for the 10,000 feet. We're not looking to see what happens above that. And so you've got some questions here. A key component of this is the 1,800 feet right there, and how fast it's going to go. 1,800 feet per minute, that whole section will be used. If it's per minute, we know that we're going to be multiplying 1,800 times something. So if you just stop and think about it and analyze it, after 1 minute, if it's 1,800 feet per minute, after 1 minute, you're 1,800 feet off the ground. After 2 minutes, you multiply it by 2, and now you're 3,600 feet off the ground. So there's not a lot to really talk about here. You'll discuss the independent and the dependent quantities that are associated with it. We spent a lot of time talking about independent and dependent, so I think you can fill that out. This shouldn't take us very long. This is just a simple analysis, not much math here whatsoever. Here's our first table that we're going to fill out. and the 1800 is a key component of this, and you're going to want to fill out what the quantity is and the units. That's minutes, hours, seconds, whatever the units are, and what the dependent quantity is, and this will be independent. Now this chart is backwards to what we normally see. Normally we would see, oh no, I'm sorry, I messed up there. This is the independent value, this is X, and this is Y. And you're going to have to come up with an equation that goes in here to plug in the independent and the dependent quantities. You're going to multiply this times some number that you're going to create in this graph and come up with the dependent quantities. Okay, this is one of the terms that we were going to talk about. This is the first difference right here. And the way you do these problems is that you're going to take these two right here and you're going to subtract them. And that gives you one of the first differences. Then you take these two and subtract them. That's another first difference. And you take these two and subtract them, and that gives you the third first difference. Down here, pretty simple table for you. Here are the ordered pairs. If you take a look, 2.5 and 4500, there they are right there. And 3 and 5400, there's that ordered pair right there. If you want to figure out what is taking place, and remember, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that is the equation of a slope that we had from last year. And you may be using that equation to find out the differences. What are the ordered? What is the slope of this thing by plugging in? And any one of these can be y sub. This can be y sub 1. That can be y sub 2. Subtract them. Here's if this is x. If this is x sub 1 or y sub 1, this is x sub 1, and this is x sub 2. Put them in the equation. You should remember how to do that. Not much on this page. Number 13 here is a really interesting problem for you to think about. It's a great discussion problem that your group ought to be able to take a look at. Put it into some equations, put it into some logical thinking. You may want to do some drawing. If the car travels at 20.5 miles per hour, with the plane, comparing the car and the plane, do some logic. I don't know if you really need an equation here. It might be a logical problem, and think through it. Here's a table for you to fill out. You're going to figure out what the unit rate is in each one of these, the contextual meaning and the mathematical meaning. The contextual meaning, write in what you think it is. Contextually or through context, where is the airplane? Mathematically, what is the formula? They're going to write the function just a little bit differently to begin with, and then you're going to start to plug in some values in this h of t over time. And h of t, what function family does it belong to? Is it going to be linear? Is it going to be quadratic? Is it going to be absolute? Exponential? Tell me what family it belongs to. I think you should have a pretty good hint. I don't believe that airplane is going to do anything but stay on line. So that should give you a hint as to what family it's going to belong to. This page they're going to ask you to graph it. What's the slope? Remember y2 minus y1 over x2 minus x1 will give you the slope. What's the x-intercept of the graph and what's the y-intercept? And explain how you determine each of these intercepts. It ought to be fairly simple. The airplane is on the ground. Where does it start? In both the x and the y. And then it leaves the ground. Where is that x and y intercept? And what does the x and y intercept mean in terms of the problem situation? I think I just sort of gave you a pretty good hint there. This is just a continuation, and you're going to be plugging some values in. Look at this. Look at these equations right here. This ought to give you some idea as to what you're going to do with these problems right down here. Where do I put the 3? And how do I multiply this out and figure out what each of these four answers are? Same thing on this page. You look at the equation and here, and it's going to give you some information for these four answers, four solutions right here. On this particular page, we talk about a solution and an intersection point. The solution of the linear equation is any answer or solution that makes the sentence true. The intersection is where the graphs intersect. I think you're going to find a very close relationship between what the solution of a linear equation is and what the intersection point is. In this particular graph, it tells us that the plane, to determine how many minutes it takes for the plane to reach 7,200 feet, using your graph, you need to determine the intersection of the two graphs represented by that particular equation. 7,200 equals 1,800 t. 7,200 is a constant. It's that line right there. 7,200 feet off the ground is never going to change. But how soon the airplane gets to 7,200 is the question that we're trying to answer. And at a rate of 1,800 feet per minute, how long will it take to get to 7,200? And then once you figure that out, what is the ordered pair of that solution? And right here it shows you. It's over 4, 1, 2, 3, 4, and up to 7,200. So those are the ordered pairs of where this thing is going to cross. So now you've got some questions to answer, but understand the solution and the intersecting point. Now we're just going to use some information to finish this graph, number 5, and then number 6, compare and contrast your solutions. This will just be a thought process problem. Here are 3 important ways for you to determine and interpret a graph. What is the advantage of seeing it in a table? I want you to explain that. What is the advantage of just taking a look at the graph? And then what is the advantage of seeing it in an equation? Write down your thoughts and perceptions on those 3, and then of course finish the rest of it. This page is just to help you grasp the idea of undoing problems. This problem is a strict undo. This is a multiply first then undo. This is a combine like terms and then undo it. This is to multiply everything by 6 first and then subtract 2 and undo the problem. Okay, we're going to go on a little world tour here. We know that if an airplane goes up, it's got to come down. So we're going to analyze that coming down, and then we're going to add to it the fact that we're going to end up in a different country. And when you end up in a different country, you're going to have to change your money so that it can be used in a different location. And so part of this is not only what will be the rate of descent, but then we're going to talk about what is the rate of change to change your dollars to pounds. You're going to see a symbol later on in this section that indicates that it is a pound. I'll point it out to you. So here's a table that just talks about the descent. We're now going to do the exact same thing, only we're going to be coming down. Normally airplanes descend slower than they ascend. Usually they take off quickly and power up to the height, and then about 45 minutes away from the airport they start to slow down, and they slow down at the same rate and get on what is called the glide path. They make contact with the tower. The tower then makes certain that the radar is working correctly. The controller in the tower will tell the pilot where to turn and how much to turn and how much to bank and level off, and then to make certain that the rate of descent is such that he'll actually hit the runway. Quite a science, actually. Here's a chart like we've had before. Remember, this book does review many times the work that you're doing, and so here's a chance for you to review some of the stuff you did in section 2.1. Okay, those last pages, I just skipped through them because you know how to do them. You did them in 2.1. We're just following in 2.2 now. All right, so this particular page, problem, making the exchange, we're going to change U.S. dollars. We've landed in the United Kingdom, which is England, and they need to have you changed your money from dollars to British pounds. And as I told you, I was going to show you this symbol right here, that little funny looking L in front, is a pound symbol, and the 0.622101 is how much of a pound there is in every dollar. You're going to use that number throughout. Now don't get hung up on that little pound sign. It looks like this, and it's got lines in it. And that's not a very good pound sign. I should know how to write them because I lived there for a couple of years, and that's a pound sign right there. We'll scrub this one out. It didn't look very good. Actually, let's just erase it. Okay? And so changing money to pounds, depending upon where you go. If you go to Italy, it's lira. If you go to France, it's francs. If you go to Germany, I believe it's a krona. Each country over there has their own set of money values. However, just recently, the European nation has gone to a common currency called the euro. And so everywhere you go in Europe now, you can exchange your money one time, and it'll all work. I know when I was there, we went to visit Germany, and so we landed in Munich and had to change our money from dollars to kronens. We then went from Germany to Italy. We had to change the kronens into lira. We traveled through Italy a lot, quite extensively. Then we went to Sweden and had to change it into Swiss francs, I think is what they used. And so we were changing money all the time. Now that with the European Union going to the euro, you can travel throughout Europe and not have to change your money. Here's a table that talks about changing, and again, this is a good discussion for you to sit down with your group and look and see what's happening with the rate of change and how much each person has and what's going to happen and who gets the most money depending upon which direction they go in terms of changing money to pounds and what the exchange rate is. I know we learned when we were over there that changing money at the airport was not the best place. There are places of exchange throughout the city, and you can go into these little places where they're a little tiny shop, and you'll see a sign out front, and you know that it's an exchange place, and you can take your money there and get a better rate than if you do it at the airport. These next few pages are calculator problems, and we can go over these together, but there's new things for you to push on the calculator, and it's step by step, pretty clear as to what they want you to do, and you'll be pushing all sorts of new buttons and come up with a solution. This last piece here is just learning to use the graphing calculator a little bit more. We'll be doing some practicing and plugging some values in and letting you graph those. On this page, we're going to have you use the intersect feature right here. It's talked about on the previous pages how to use that on your graphing calculator. And so you're going to have these two equations. It's going to graph them, and it's going to intersect. It's going to be kind of fun for you to watch what happens. And then on this page, just fill out the always, sometimes, and never as you read through these A through F. And we're done with this section.